friends, in this video we will study the programming of 8051 microcontroller. We will study the programming steps which are to be taken whenever we are writing a program for the 8051 microcontroller in the assembly language. So which steps are to be followed? Let's study in this video. We know that the 8051 microcontroller, it can perform various types of operations like arithmetic operations, logical operations, data transfer operations and machine control operations. So various types of operations can be performed by the 8051 microcontroller. And this microcontroller performs these operations with the help of the instructions. With the help of these instructions, a program is written and that program is going to perform that particular operation. Now, these instructions form the instruction set of the 8051. So, the complete instruction set of 8051, it can perform the various operations, and these operations, as I have told, that they can be arithmetic and logical operations, the movement of data. So, let's see that what types of operations are performed with the help of instructions in the instruction set of 8051. So, the 8051 instruction set, it can do first the ALU, that is the arithmetic and the logical unit, in combination with the various other registers in the 8051. They can be controlled by the binary operational codes to perform the arithmetic operations. So the first type of operations which the 8051 instructions can perform are the arithmetic operations. Second, the instructions, they can be used to transfer the data inside the CPU. Means inside the microcontroller we are having various registers, we are having the memory. So if we want to transfer the data from one memory location to another memory location, or from one register to another register, from one register to a memory location, so the transfer of data can also be done with the help of these instructions. Next, these instructions can perform the logical and the arithmetic manipulations in the microcontroller. Okay, logical operations means like logical AND, OR, XOR, NOT, these operations, and arithmetic like addition, subtraction, multiplication, division, complement. These operations can be performed with the help of the 8051 instruction. Also, with the help of the instruction set of 8051, the microcontroller can make decisions based on the manipulation results. If we are getting any result of the operation, on the basis of that result, if some decisions are to be making, like if two numbers are compared and if we have found that this number is greater than the other number, then let's perform the next operation. So it can make decision based on the manipulation result. result. Suppose that if result is coming out to be 0, then do this operation. If the result is not coming out to be 0, then do the another operation. So on the basis of that, decisions can be made with the help of the instructions. Also, the microcontroller can move the data into and out of the microcontroller. With the help of the instructions, the data can be moved into the microcontroller and out of the microcontroller. Suppose that microcontroller is communicating with some other device, okay, and those device want to give some data to the microcontroller, so that will be an input data. And if the microcontroller want to send up some data to the external devices, then that will be the output data. So data can be moved into and out of the microcontroller. So with the help of the instructions present in the instruction set of the microcontroller, all these types of operations can be performed. But the microcontroller, it cannot make the decisions by itself. It cannot do all these operations by itself. We have to specify the microcontroller about all the details, that which is the input data, which is the output data, what operation it has to perform, where the data will be available, where the result is to be displayed. So everything is to be provided to the microcontroller by the programmer. Okay. So in the microcontroller, we are having the hardware part and the software part. So hardware part includes only the logical circuitry which is present in it, okay, the electrical circuits, the logical gates which are present in it, that constitute the hardware part. And the software part, it includes the instructions and the programming part, okay. So whenever we want that microcontroller should perform this task, so we have to write the program in that. So whenever we are writing a program in the microcontroller, which steps are to be followed and in which sequence that those steps are to be followed, let's see that. Okay, let's study about that. So whenever we are writing a program in the 8051, the steps which we followed are, there are 5 steps. Step number 1 is define the problem to be solved. First of all, we should define the problem which we want to solve. Okay, that from where we are getting the input, where the output is to be displayed, what operation is to be performed. Okay, so we have to define a problem, that what task we have to perform with the help of that program. Okay, then step number 2 is solution plan. In the first step, we know that what is the problem, what task is to be performed by the microcontroller. Okay, everything is in front of us. Now how we are going to solve that problem, that comes in step number 2. Okay, then step number 3, flowchart. When we have got the solution that in this way we are going to solve our problem, then in the third step we will draw the flow chart, that which what will be the sequence of solving the problem, which is the first step, second step, third step, in which sequence we are going to solve the problem. So that is defined in step number 3 with the help of the flow chart. Then in step number 4, we will write the program for that problem. And in step number 5, we will check the result. So whenever we are doing programming, assembly language programming in the 8051 microcontroller, these steps are to be followed. First of all, we will define the problem which we want to solve. Then we will find the solution for that problem. In the third step, we will draw the flow chart, that in which sequence we are going to solve that problem. In the fourth step, we will write the program for that problem. And in fifth step, we will check the result, that whether our program is running accurately or not, giving the accurate results or not. Okay. Now let's study these steps in detail, that what you have to perform in all these steps with the help of one example also. So in step number 1, what we do, we define the problem which we want to solve. Now in this step, what are the things which we will do? We will first define that from where we are getting the input. Okay, so first thing is, that where are the inputs of the program, whether the data which we are using in the program, whether that data is stored in the memory or it is available in a register, okay, or it is directly available in the program. So that is to be decided in this step. So in this first step, the problems which we will cover in this and how we are going to define a problem. First, we will find out that where are the inputs to the program, whether direct data is available to the programmer or the data is stored in the registers R1 to R7 of the selected register bank, or the data is stored in any memory location, or the data is stored in a memory location whose address is pointed by the registers R1 to R7 of the selected register bank. So we are having these 4 options that we can get the input data from these locations. Okay. Now when we have got our input, then the second thing which we will do is, what is the operation to be performed? Okay, like if we want to do the addition, okay, addition of two datas, then a plus b is the operation. If we want multiplication, then a into b. If we want division, then a divided by b. Okay, so which type of operation is to be performed in the program, that is to be decided in this first step. Okay, then third thing we will do is where we want the output. Okay, after we have done the operation and we have got the result, now where this result should be stored or whether this result will be displayed. Okay, so where you want the output. So in this first step where we are defining our problem, first thing we will do is, first we will decide that from where we are getting the input. Second thing, we will decide that what operation we have to perform on that data, and third thing, that where we want our output, where the result should be stored. Okay, that is covered in the first step. Now comes the second step. In second step, we find the solution to the plan. Solution plan is decided. Now first first step we have known that inputs are here, output is to be stored here, and this is we have to perform. Now how we are going to perform that operation, that is to be decided in step number 2. Suppose that we want to do the addition of two numbers. We know that one is directly the data is available to us, and the second number will be stored in the register. Now how we are going to add them and how we are going to store the results in the accumulator, that is to be decided in step number 2. So in this step number 2, first thing you will do is how are you taking the input data. In first step, you know that our input data is stored in the register, or it is stored in the memory location. Now how you are going to take that data from that register and from the memory location, so that you will decide in step number 2. Also, which method you are using to solve the problem. Suppose you have to do the addition. Now how you are going to add these two numbers, okay, that you will decide in step number 2. Suppose that you are going to use the addition instruction, and then you will add those in two numbers, so that you will decide in step number 2. Also, what are the steps in this method? Suppose you are doing the addition, so which steps you will follow, how you will get your first data, how you will get your second data, how you are going to add these two numbers, which instruction you are going to use, what steps you will follow, everything you will decide in step number 2. Like means that you are planning that in this way I am going to solve this problem. Okay. Next, how will you output the result? Suppose you have to display the result or store the result in the accumulator or in the register number 1 of register bank 0. Bank 0, you have to store the result in register 1. Okay, R1 register. So how you are going to display the result or output the result at that register, that is also to be decided in step number 2. So in this step number 2, you are portraying a phenomena or the steps that in this way I am going to solve my problem. Means you are planning that how you are solving that program. Okay. Now comes step number 3. In step number 3, you have to draw the flowchart. Flowchart means that you have in the step number 2, you have known that in this way I will solve my problem. So in step number 3, you will draw the flowchart for it, that this will be my first step, this will be my second step. First I will take the input from this, then I am going to add those two numbers, then I will display the result, then I will transfer the result to that location. Okay, so in the flowchart you will define that what will be the sequence of solving that problem. Okay, so flowchart is the pictorial representation of the various actions which you are taking for solving that problem. Now in this flowchart you will use different signs, like arrow will be used. Arrow will indicate the direction of the program. Okay, like in which direction the program is being followed. So arrow is used to indicate the direction. Then we are having parallelogram. Parallelogram is used to indicate the input or the output unit, that from where you are getting output and from where you are displaying the output, so that will be indicated in a parallelogram. Then you are having the rectangle. Rectangle is used to define the process operation. Okay. After that, you are having a double-sided rectangle. This double-sided rectangle, it defined the predefined process. Predefined processes like if any subroutine is to be executed, okay, so that subroutine is predefined, that whenever you are going to call this or you are going to execute this interrupt, then this subroutine will be executed. So these are the predefined processes in the microcontroller. After that, you are having the diamond unit. This diamond unit indicates is the decision unit. Whenever you are placing some conditions in the program, that if this condition is to be is true, then this will be done. If this condition is false, then this operation is to be performed. So this is the decision unit. Then we are having the oval. This oval is the start and stop unit. In the starting and at the end of the program, we will have the start and stop unit, which indicates that from here the program is starting and at this the program has ended up. Then we are having the circle with an arrow. This represents continuation. That continuously these steps are to be followed again and again. So these are some symbols which are used in the flowchart, and with the help of that we are doing a visual representation of the steps which are being followed or how we are solving our problem. Then comes step number 4. Step number 4 is the program. So in step number 4, we are going to use the assembly language, the instructions we are going to use, and with the help of instructions and those assembly language, we will write the program for that problem. So you have drawn the flowchart in the step number 3. So instead of the every symbol in that flowchart, write the instruction for that. So go on putting the instruction instead of the flowchart blocks. Replace those blocks with the instructions and you will be able to write the program for that problem. Then comes step number 5, where we will check the result. So in this step, whatever instructions we have written in this step number 4, we are going to find the codes for those instructions, because we are writing the program in assembly language, but when we are inputting that program into the machine, then we have to write the machine language, that is we have to write the machine codes. So we will find the codes for the instructions. Feed those code in 8051 system and then execute the program. And when we will execute the program, we will get the result. And then when we are getting the result, we will check that whether we have got the correct result. If not, then we have to make the corrections in the program. If we are getting the correct result, it means that we have written the right program. Okay. So these are the steps which are to be followed whenever we are writing or programming the 8051 microcontroller. First, define the problem which we have to solve. Second, find the solution plan. Then third, draw the flow chart. In the fourth step, write the program, and in fifth step, check the result. So I hope that this topic, programming steps in 8051 microcontroller, is now clear to you. Thank you.